Okay, YouTube, in my last video, I kind of defined the notion of radian measurement. We said that the number of radians of rotation that an angle is, basically all it is measuring how many times the radius divides into the intercepted arc length around the outside. And we use the letter S to indicate that arc length. And so what we're going to do in this video is we're going to kind of tie together how degrees relate to radians and vice versa. That is to say, well, we know there are 360 degrees in a full rotation. Well, how many radians are in a full rotation? And can we use that to kind of help us navigate more in radians and also convert between degrees and radians? So in this video, we're going to focus on how we convert between the two. The next video, we'll talk about some pretty common radian measurements. But let's start with this. Converting between degrees and radians, we need a conversion factor. That is to say, like, we often say things like 12 inches, 1 foot. Or we might say 1,000 meters and 1 kilometer. These conversion factors come in really handy when we want to cancel out units that we're not interested in. And so what we're going to do is we're going to start with this. We're going to say that because we know that the number of radians in an angle is equal to the arc length divided by the radius, or how many times the radius fits into the arc length, what we're going to do is we're going to take the arc length of one full rotation, which is this right here. And if this looks familiar to you, it's because that S, or the arc length one full time around a circle, is also referred to as the circumference. And we give that by 2 times pi times the radius, or at least pi times the diameter. But this being said, what this really means is that we could find the number of radians in a 360 degree rotation by taking the circumference and dividing by the radius. Or that is to say, we take 2 pi r and divide by the radius. Or that is to say that the radius cancels out, and guess what? Da, 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 we get this. And so here's what we want to basically admit. We say that the angle theta for a full rotation is equal to 2 pi. And so we're going to say conversions. I'm going to write down some basic ones right off the bat, and we'll get into the nitty-gritty later. But in terms of conversions, we would say degrees on the left here, and we'll do radians on the right. And the three big ones we want to get out of our system right now are these. We say that 360 degrees, we just learned, is the same as exactly 2 pi radians. And so the fabulous thing about this is that if you cut 360 in half, like a half a rotation, what would that be? Well, if a full rotation is 2 pi radians, then a half a rotation, or a straight angle, is just a 1 pi angle. And if we were to cut this 180 in half and go to 90 degrees, we say that that is a half of a pi rotation. The big one, though, I want to kind of put a box around, is this one right here. And because, we could say that, 360, let me write this down here, 360 degrees is the 2 pi, and I am going to label this here radians, but that's really the same thing as 180 degrees over just 1 pi radians. And that's the same thing as also 90 degrees over pi halves radians. But in terms of the easiest conversion factor to deal with that compares degrees to radians, we know that 180 degrees is to 1 radian. Okay, they are the same thing, or equivalent amounts of rotation, let's put it that way. So in order to convert between these two things, what we're going to do essentially is we're going to borrow from this 180 to pi, degrees to radians comparison, and using this basic relationship that pi radians is 180 degrees, we're either going to convert from degrees to radians by multiplying by pi radians over 180 degrees, or from radians to degrees by multiplying by 180 degrees over pi radians. You'll notice that in either instance, you're multiplying by one of these. So what I can tell you is you're never going to mess this up so long as you can cancel your units out and do conversions. So let me go ahead and kind of look at a situation with you here in which this would be helpful. We say 60 degrees. This is something I'm interested in doing a lot, is converting from degrees to radians, radians to degrees. Let's take 60 degrees. I'm going to write this as 60 with the degree symbol. I'm going to put this over 1. And what I'm going to do is I'm either going to multiply by either pi radians over 180 degrees, because they mean the same thing, right? Or 180 degrees over pi radians. And what I want you to consider is that if you were to multiply by this right here, okay, then you would have degrees times degrees, which would be square degrees, which would be 2 times the degree symbol. No, actually, the point here is that your units won't cancel out. And so I'm purposefully going to multiply by pi radians over 180 degrees. But the rationale behind this is that if I do this, then now my degrees cancel out. And look what I'm in. Now I'm in radians, even though I don't even need to write the word rad. I know I'm in radians. So what we're going to do is we're going to cancel out our units here, which are our degrees. I'm also going to look for any common factors. That is to say, 60 goes into itself once. 60 goes into 180 3 times. So now we're going to multiply straight across. And what we end up with is pi times 1 on top over 1 times 3 on bottom. And what we're going to do is we're just going to label this with either radians, or we're just not going to label it at all. And so what we could say is 60 degrees is the same thing as pi thirds radians, or I'm just going to label this with a theta here if these are both theta. So easy enough to convert. Now, one thing I want to say as we go forward to this next one, obviously this is in degrees as well. We're going to put this over 1. And we're also going to multiply by pi radians over 180 degrees. But the thing that I want to point out here is this. When you do your conversions, I always think about it this way. Put the unit on top of your conversion factor that you're converting to. That is, if I'm going to radians, put radians on top. Put pi on top. If you're going to degrees, we'll put the 180 number on top. So again, we're going to start by canceling out any units that cancel out. I know that 90 goes into both 180 and 270. It goes into 270 3 times, and 180 goes into it twice. So we're going to look at this as kind of 3 times pi on top, so we get 3 pi. And on bottom, we get 1 times 2. So we say 3 pi halves radians, that's the same thing as 270 degrees. And last but not least, negative 300, kind of a, a negative angle here. Does this work also with our conversion factor? Well, I suppose it does. We say pi rad 180 degrees. So our degrees are gone. I suppose that I could divide both of these by 10 and that would cut off a 0. Now what goes into 30 that also goes into 18? I suppose 6 does. So 6 goes into a negative 30 negative 5 times, and 6 goes into a positive 18 3 times. So on top we end up with negative 5 times pi, and on bottom here we get 1 times 3. So negative 5 pi thirds, and we're going to label this radians. So now going on to these last two, what you're going to see here is that we're in radians to begin with. What we want to do is convert to degrees. So likewise, just like with our other conversions up here, we're going to take what we have here, which is this pi fourths radians, and I suppose you could label this, we say rad, take this and we're going to multiply it by 180 degrees over pi. Remember what I said about we want to go to degrees, we'll put degrees on top. And we'll say pi rad on bottom. And so some things happen here. Our radians cancel out. Again, you don't have to write radians, but you'll notice that in this case also our pi's cancel out and just become 1s. About 4 and 180. Now it's good to know, just saying, that there are 4 45 degree angles and a 180 degree angle, but 4 goes into itself also once. So really what we get here for a pi fourths radian measurement is that we have a 45 degree angle. That's the same as pi fourths radians. Okay, so looking at this next one here, again, another negative angle. We're going to say negative 4 pi thirds rad, and what we're going to do is we're going to take this times 180 degrees. We want to go into degrees, over pi rad. Again, our radians cancel out, our pi's cancel out. 3 and 180 share a common factor of 3, so 3 goes into itself once. 3 goes into 180 degrees 60 degrees worth of times. And so we're going to end up by multiplying here. It looks like 1 times 1 on bottom, but on top we get negative 4 times 60 degrees, which is a negative 240 degree angle. So a negative 4 pi third radian measurement, that's the same thing as a negative 240 degree angle. And then my favorite one. This is my favorite because it just says 6 radians, rads, radians. And people are like, where's the pi? And it's like, well, you don't have to have a pi. 6 radians just means that you have some central angle here where the radius fits in the outside 6 times. Okay, so the question is how many degrees is that right here? And I would tell you that, by the way, 6 radians, kind of like if this is your radius length here, it would wrap around like all the way almost around one time. And I just know this, just bear with me here. But we'd say if this is 6r, this is r, basically the radius fits into the outside 6 times. Let's go ahead and take a look at how many degrees that would be. So we would say 6, all we're going to do is say 6 rad, and we're certainly still going to take this times 180 degrees over pi rad. And so what you're going to see is that your radians cancel out, and you end up with 6 times 180 degrees over pi degrees. And so all this means is you just need a calculator. That's all this means. And so to maybe like 2 decimal places, let's take a look at this here. We have 6 times 180, of course, gives us 1080, and we're going to divide this by pi, which is about 343.77-ish. So approximately 343.77. That's how you convert back into degrees. And look at this. It's totally reasonable to think that that's a 343.77 degree rotation. Cheers.